Okay, cool. Okay, we are live.
All right.
So, sorry everyone for waiting. Okay, we got some viewers, so sorry everyone for waiting. We had some trouble configuring the right Zoom meeting, broadcasting to the right event. So, without further ado, Miško, welcome and thank you. It's an honor to have you here in our channel. We have Miško here, who is going to talk about Qwik, which is an amazing front-end framework. And I'm not going to talk much this talk. I'm just going to be on the chat live. If there are any questions, you can ask, and I will ask Miško. So this is a free talk, right? We have time, and we're going to see some demos, and it's going to be fun. And that's it on my side. Please, Miško, introduce yourself.
Hi, how's it going? I'm Miško. Let's see, I'm a CTO at Builder.io. We are a visual headless CMS. Think, kind of page builders like Wix, but headless, meaning that it runs on your technology stack rather than on somebody else's. One of the things we care about a lot is to make sure that our customers are fast. And so for that purpose, we're working on two very cool technologies. One is Qwik, which is a new kind of a framework, which is resumable. I mean, we'll talk about most of the time about it today. And also about Partytown. Partytown is a solution that allows you to take your third-party scripts and move them over to web workers so that you can offload the main thread. Right? Okay, so what is our goal here? I think our goal is very simple, which is that the amount of JavaScript that is downloaded to the browser and has to be executed on startup is way too much. And it's resulting in a very slow startup performance for the websites. And so the goal we want is, faster startup. Like everybody wants a faster site, right? That's easy to kind of look forward to.
Time
and
is
so,
equal.
Yes. And by the way, jump in, ask questions. I love questions. I love being interrupted. Don't make this a monologue for me.
Oh, yeah.
It's a lot more fun. Yeah, no. Go.
For the sake of everyone, just to get to know you a bit, because you're the creator of Angular.js, so please let's just mention that, right?
Yes, I created Angular and Angular.js, or rather the other way around, Angular.js first and then Angular. So I feel like I maybe know a little bit about frameworks. And so all existing frameworks, whether it's Angular, Vue, React, Svelte, add your favorite one, are what we call a resumable frameworks. And the reason I call them replayable. And the reason I call them replayable is because they have to do the work twice. Maybe I can show a few slides here. So let me see if I can get my slide deck going here. And
maybe. Yeah, you can share your screen now.
I think so. Hold on. Let me just get them up and running quick. Here we go. And share screen, the whole thing. Here we go. Okay. Okay, so I think we need to talk about, and I need to fix the slide, this click shouldn't be here. We need to talk about how existing systems work to kind of appreciate how Qwik is different. So existing systems, I think we got here because at some point we decided that we wanted to have all of our website done in JavaScript. And I think that's a good idea. I think it's great to have everything done in single language so you don't have to worry about server side and the client side code. It's just, one client side code. It makes things easier. And so the way this works is you send it HTML, and that HTML just renders a blank page. But what's hidden inside of this blank page is a script tag. And this script tag downloads a whole bunch of JavaScript. And that JavaScript then starts executing. And once the JavaScript executes, you can render the page. And so the result is a page that looks like this. And this is the point where you can interact with the page, right?
Right.
And the problem here is the user is staring at a white page for a very long time before output happens. And so to work around this problem, people created this thing called server-side pre-rendering or static site generation, SSG. Different name, but it fundamentally works the same way. So what we do here is we send HTML, but notice this HTML is bigger than this HTML. And that's because it's not just a blank page now. It now has the actual website inside of it. And this HTML was generated on a server by executing basically these three steps, right? So we took these steps up here and we executed them on a server so that we can produce the HTML. So we literally took this block here and pre-executed it on a server, and we got the HTML output.
Right.
And now we have a page. Except that this page, you can't interact with it. It's dead, right? It's not interactable. And so no JavaScript, right? So it appears faster. And so that's good, right? Like, people like that. But now the page has to go and download the JavaScript and has to execute the application. And it has to re-render or reconcile the application. And then we produce basically the same exact page. And it's this point where you can interact with it.
Right.
And the thing I want to point out is, like, look at this. It appears faster, but it's actually slower, right? Because we had to do the same amount of work here, but we also had to download this HTML that's bigger. And if you think about it, there is a duplicate amount of information here, right? The server produced this text here, but this text is also found inside of the JavaScript. And the other thing to point out is that if you were to, I know we are pre-rendering this page here, but if you were to replace this page with a blank white page, the JavaScript and the execution and the reconciliation will still rebuild the whole page. And really the only difference here is that we're just running the same thing. We're literally running the same code up here, down here. There is no difference. It's the same exact thing. It's just that you happen to have a page that looks like it. And when this finally finishes running, you throw this page away and you replace it with this page. Now,
so instead of the white page, you get to see the website, which is good, but you're not getting the interactivity. So you can't do really anything. So
yeah. And I really want to stress the fact that, like, what's actually happening, if you think about it, is that this page is thrown away and it's replaced with a page that looks identical like it. And I know it's not 100% true because, you know, many frameworks today can do reconciliation. What it means is they try to reuse the DOM elements from this page to be here so that we don't actually throw it away. But even if you replace this and you throw it away, you will still render the same page because the JavaScript and the execution of the app fully contains all the information necessary to rebuild the page, right? And so you end up with this duplicate information problem. And this is the reason why you're actually slower.
Yeah. And just to make things on the, you know, just to make sure we get the terms right. So this is kind of a multi-page application with single-page application combined, right? Like, this is what...
Yeah, exactly.
This is what I'm talking about Remix in my YouTube channel. So this is what Remix and Next are doing, right? Okay.
Actually, this is what all the frameworks do, because all of the frameworks essentially work this way, that they're, you know, with few, some frameworks are starting to dabble in a server-side pre-rendering where it's actually a important part to the output. But for the most frameworks, if you were to replace this section right here with a blank page, the result would still be the same, right? So they will rebuild the stuff that's missing. Some frameworks, this is not true, but these are kind of more not mainstream frameworks like Solid, Marco. Those frameworks rely, actually, they try to remove the duplicate information, therefore they rely on this HTML more. But for the most part, all the mainstream frameworks work this way.
Okay.
And so let me show you. So this particular thing we call replayable. And the reason why I'm calling it replayable is because this is not shown here, but the generation of this HTML here forced us to execute the application on the server, right? So the application executed once on a server, and then the server, you know, produced HTML and shut down or whatever, it was thrown away. And then the same exact application executes in the same exact way, produces the same exact output on the client. Right. And so we replay the application twice, once on the server, once on the client. Now, there's corner cases where you can say like, yeah, but I'm doing server-side pre-rendering or static site generation or something like that. Yeah. You know, those are details, but like fundamental mental model is that it's running twice, once on a server and then again on the client, and replaying is the way that the client essentially restarts, right? Okay. And so now let's look at the resumable frameworks. And so resumable frameworks are different. I need to fix this click. This click is here a little too early. Again, just like this mode, you get the HTML, and this HTML contains the output. So far we're the same. But it's at this point where you can actually already interact with the page. And this is kind of cool, the fact that you can already interact it at this particular point. And we'll dive into it a little more how that works. But the next bit is you, so obviously it appears faster, but because you can interact already, it actually is faster. It's not like the previous case where like, oh, it appeared faster, but you actually was slower at interacting. You can actually interact at this point. And so it actually is faster. Now, the next thing that happens immediately is we start downloading the JavaScript. Mm-hmm. And at this point, you can say like, yeah, but like this JavaScript is smaller than this JavaScript, you're cheating, right? Well, right. We actually remove the duplicates. So the thing here is the reason why this JavaScript is smaller is because we can look at this HTML and say like, actually, there's duplicates all over the place, and we can remove them. And depending on how complex your website is, etc., this JavaScript might be smaller or bigger, but it will never be bigger than the full app, right? So this is kind of the worst case scenario when it's full app.
And by the way, how can you click? I mean, how can you click if you don't have any JavaScript yet, or you do have, or you keep the state?
That's a good question. So there is a tiny little, what we call a quick loader. So there's a tiny piece of JavaScript, about a kilobyte in size. And this JavaScript is inlined directly into the HTML because it's so tiny, it's not even worth making a round trip. So that quick loader is inlined into the HTML. And what the quick loader knows how to do is it knows how to listen to DOM events, such as a click. And then when you click on a button, the event is captured by the quick loader, and the quick loader looks at the DOM tree, and based on the DOM tree, it tries to figure out what additional JavaScript it has to download and then execute. And this is why at this point it's clickable, but it might not be executed immediately until this JavaScript downloads. But this JavaScript downloads eagerly, regardless whether you click on it or not. Right. Nice. So at this point, an interaction is guaranteed to be processed, whereas here an interaction is not guaranteed to be processed until this point here. So in this point, the interaction is guaranteed to be processed, but at this point right here, the interaction is guaranteed to be processed with no delay. Right. So here there might be a slight delay because the JavaScript has not yet downloaded, but here there's guaranteed to be no delay. So worst case scenario is that this arrow is actually, here, which still saves huge amount of time from this point of view forward. Okay, so we kind of explained how this missing JavaScript here is because the duplicates got removed. But the next big thing that's interesting is that there's no execution of the app and there's no reconciliation. Those bits get...
One, sorry.
No problem.
First of all, we're talking right now about Qwik. I mean, resumbility is a Qwik feature, right?
Correct.
Okay, so I'm going to ask, how are you doing the duplication remove, which is not it's not available in other frameworks? Why don't they do that the same as you do?
Yeah. Well, the short answer is that they need, the reason why the frameworks have to re-execute everything here is because in order for the framework to run, the framework needs to have information about your application, right? We don't really think about it because we usually think about the state of our application. We don't really talk about what the framework has to do because that's just given. But a framework also needs to have information, right? And so the example of information the framework needs to have a component boundaries. It needs to know the locations of the listeners. It needs to know what are the props for those components, right? It needs to know the reactivity graph of the system. And so those pieces of information are things that the framework needs to know in order to do anything useful, right? So somehow the framework needs to get this information. And the way it gets this information is by executing the application. If you think about it, a full execution of the application is how frameworks have always worked. And it is how the frameworks have always collected that information, right? Because they just simply execute the application end to end. And as they visit every single template, they realize, oh, this is where the listeners are. This is where the component boundaries are. This is where the reactivity graph is, and so on and so forth. So this is what's happening here. And the problem is you can't remove the duplication in this world, because imagine you have a situation where the top level component is a component that like contains like your username or something that has to be reactive. And inside of it is a component that isn't reactive. But the child of that component that's even below is something that is reactive. And so the problem is you can't remove the middle one, even though the middle one will guarantee to never be changed. You can't remove it, because if you did, then how would the framework know that there is this child over here that needs to have reactivity over there, right? Yeah. So removing duplicate information in the framework would automatically prevent the framework from collecting sufficient amount of information about the application to make the application run.
I see.
So the magical bit here is that we can serialize this information. So this HTML contains not only the tiny little JavaScript, but also information about where the component boundaries are, where the listeners are, what is the reactivity graph. All of that stuff is in here, so that this code right here never has to execute, right? We don't, not only that it doesn't have to execute, it is impossible for this code to execute, because execution of the code would require the full graph of components, which we don't have because we remove duplicates. Right. Okay. So this resumability is not an optimization. It's like we can't even do it, even if we wanted to. And so this is why it's important for the server to serialize all this information for us. And this is why we mean by the system being resumable, because when we get to the client just continues where the server left off, rather than rerunning the application from the beginning and collecting the information that way.
Amazing. So I have two interesting questions I think everyone wants to know. First, how does it look like in the code? And second, what is the results? What do we gain from it? I imagine performance-wise, we get great results. So we'd like to see some of it. And yeah, great.
Yeah, so let's talk about great results first. So actually, let me see if I can. Okay, so these are the results you're going to get out of it. So on the right-hand side is a Qwik website. On the left-hand side is the same exact website done using React and Next.js. And what you see is that when the website is colored, JavaScript is executing. When the website is gray, the JavaScript stopped executing. So let me show this again. First of all, the code shows up faster because there's less HTML, because we don't download stuff below the fold. And once the code shows up, it immediately goes gray, right? It immediately goes gray. Whereas the builder side of the React side of things had to run reconciliation and re-execution of the application and all the other stuff. So the reason why this takes so long to go gray is because all of the application has to be replayed once again in the browser.
And this is built with Next, you said? Next.js?
This one is Next.js, and this one is Qwik. So let me show this again. So let's go to builder.io. This is our homepage. And let's grab this URL and go to page speed. And let's grab this URL and say render. So we have a special URL where we can go and render both of them. And let's do builder/. Okay. So what I want to show you is that these two sites are identical, right? Like, I mean, this looks like a little bit of font differences in here, but other than that, it's the same exact website. You can scroll both of them, you know, it's quite a lot of them. The menu system works on the top. You know, it's basically the same exact website that we built in two different technologies. And if you look at it from the point of view of Google PageSpeed Insights, the Qwik version gets 97, right? Not only does it get 97, but it has blocking time is super tiny. Time to interactive is excellent. Again, remember, this is mobile with a slow network, right?
Amazing.
And if you look at the same exact website in Next.js, slow, but also time to interactive, blocking time is huge. And so it's a huge difference in terms of the performance between the two sites.
Right.
The other way to look at it,
I just want to, can you show us like the interactivity to try to like refresh and click right away? Oh, you did. Okay. The menu is also.
Oh yeah. So yeah, you know, I mean, this thing refreshes so fast, I can't even get my mouse over to the other side. So what I wanted to show you is we can go to performance and we can execute code here. Wait a second to collect the data. And I'm going to do the same exact thing on the Next.js version as well. Performance and do it here. And so what I'm going to show you basically is the amount of JavaScript that executed in the browser, right? And so remember, this is a desktop computer. And so what you see is this huge flame chart, right? This flame chart represents basically the execution of the application, reconciliation, rendering, attachment of the listeners, etc. So this is the Next.js. And if you look at the amount of script time, it's almost a second, right? 890 milliseconds of execution time. So this is pretty big. And you can also see it over here. There's just a lot of yellow in here at the top, right? Before things settle down. And you can see that up around 1.5 seconds, we are ready to go and everything is ready to go. These numbers are much faster than the page speed ones because these are emulating a mobile device. This is actually my desktop, right? One of the on the latest Macs. Now, if you go to look at the same exact thing in Qwik version, first thing you're going to notice is like, wait, what happened to all the JavaScript, right? So the flame chart is not as busy. The amount of JavaScript you see over here is much less. And when you look at the amount of JavaScript executed, it's an order of magnitude less, right? So it's a huge difference in terms of what would we get over here. And so this is what we're going after, is we're going after getting rid of all of this JavaScript, right?
Right. And you know, you're talking about Next, but can you explain the difference? I think you already did, but just for the sake of our viewers, the difference in Remix, this term progressive enhancement. So what is the difference between that and progressive enhancement?
Right. So the progressive enhancement basically says, let's say you have a form such as an input, like a search box, right? You should be able to type into the search box and hit enter. And if the JavaScript isn't there, then you should just rely on the fact that the browser knows how to post the search to the server, right? Right. And so progressive enhancement is an improvement, but it's not the same thing as the actual JavaScript, because progressive enhancement won't allow you to have a menu system like this, right? This is not a thing. You can't do this with progressive enhancement because that requires JavaScript. And the only thing that progressive enhancement allows you to do is kind of deal with forms, links, and things of that sort. So like I like to joke that like users don't want a progressively enhanced website. They want the full website just faster.
That's right. Yeah, that's right.
Because a progressive enhancement is basically a degraded experience until JavaScript shows up.
That's right.
Right. And so you don't want that. You just want the whole thing just faster. And this is where I think technologies that are resumable, and by the way, Qwik is not the only framework out there that's resumable. Google has had this thing called Google Wiz, which is an internal framework for almost a decade. And eBay is working on a framework called Marco, which in the next release is supposed to be resumable as well. So, you know, this is a thing that's going to happen. We like to think that Qwik is going to be in the forefront here. But I think once you understand resumability and once you understand the huge performance gains you can get, you kind of wonder why you did it any other way in the past, right?
Yeah, and you also said that other frameworks can mimic it because they will need to rebuild the entire framework, right, from the ground up.
Yeah, the problem is that the resumability requires certain additional constraints, namely around serialization, and because of that, it's going to be very difficult for existing frameworks to add this feature with backwards compatibility. It will be easy to add it in a way that you break backwards compatibility, but that means that all of your existing ecosystem of all the third-party tools and libraries and meta frameworks that run on top of you, all of those become incompatible, right? And so the question is, will any framework be daring enough to sacrifice all the existing ecosystem and basically come up with something that's essentially a new framework, right? A completely independent framework that is different from the previous one. And I'm going to predict that the answer is no. I don't think anybody's going to be able to do that.
Okay, it's recorded, so we will see.
We'll see. Yeah. Okay, so I kind of showed you kind of the point here, right? Is that the point is less JavaScript. That's really what it is. But I want to make a point here that it's not about less JavaScript in a sense of like, I think there are people out there who have this idea of like, oh, we are overusing JavaScript and we should figure out how to write less JavaScript. I don't think that's reasonable. Like, it's not about writing less JavaScript. It's about getting smarter about what actually needs to be downloaded to the browser, right? So this isn't a pitch to convince you that we should not have JavaScript, right? Or that somehow magically you need to write less. No, I think you should continue writing all the JavaScript you want. It's just, if you think about it, not all of the JavaScript is required when the page first comes up. Like, you don't need all the JavaScript until you do kind of more complex interactions. Like, for example, on this page, let me see if I can zoom out. Notice that the bottom of the page is actually missing, and actually there's a text here. It's probably impossible to read for you, but it says loading. And it's only when I start scrolling that the rest of the page shows up, right? And so this is another trick that we can do to basically say, look, it's not that I'm asking you to make a smaller site and less JavaScript. It's just I'm going to get smarter about the way I deliver the HTML and JavaScript to the browser so that it's not overwhelming the browser on startup.
So I'm guessing the next question is going to be, how does it affect the developers? Do I need to think about it when I write my code?
Yes, that's my favorite part of it. So let's dive into it. So I have this simple case here, simple demo, and we can kind of dive into it deeper. All it is, it says it has a bunch of items. And if you scroll to the bottom, on the bottom over here is a clock. And if I go to the network, and you can see the clock updates every 1 second. And let's see JavaScript. Let's refresh this again. You see that. Okay, so let me show this again, like over here. There are two things in here. These are both Vite. So because this is in dev mode, we're running Vite, and Vite, to the purposes of hot module reloading, like puts a bunch of code here. But in production, the code is not there. So what I'm going to do is I'm going to filter it out. I'm going to say I don't want to see Vite. Okay. So what I want to show you is that no other JavaScript shows up here. And let me make this bigger. And then when I scroll for the clock, the moment the clock comes into view, its JavaScript shows up, and you can see that the rendering is happening.
Nice.
Make sense? Okay.
Yeah.
So I think it's super cool because I think it's worth kind of diving into what actually downloaded. So what downloaded is this piece of code, which you can see is about 20 lines of code. And this is the code that updates the clock. And I'll show you more in detail in a second. But basically, just the code that updates the clock downloaded, and then the framework itself downloaded. No other code downloaded, right? But if you think about it, like, what about this list over here? Normal frameworks would have to download the list as well. And actually, this paragraph here it has a listener on it, so I can click on it. And if you notice when I clicked on it, more code downloaded that actually logged some text out, right? So it said the test, it logged the test. So the point I'm trying to make here is that there is a lot of code on this page. There is a header. As a matter of fact, if you go here, every time you see QV in the output, that's a component boundary, right? So you can see that there's a lot of components in this page. Even more here, more on footer. Like there is a lot of components here, but when you go to the network tab, the only thing that downloaded is really just these 20 lines of code.
Yeah.
Right? Because the system understood that, like, yeah, I know there's a bunch of other components here, but you don't need any of that stuff. You only need the clock. And nothing else needs to be present. And so let's go now look at it from the point of view of the developer, right?
You didn't download the component of the clock, like the UI of the clock was there, right?
Correct. So yeah, that's right. So let's kind of look at how the component is built, and then we can go back to see what's in here. So first of all, this is like Next.js, this is a meta framework. And so this clock is running inside of this layout. So there's this layout that renders. And if you go even further, this layout has a header and a footer. And this is where all the components are coming from, right? So this header has more components, etc. So by the time we get to our clock here, this is an example of a single component, as you can see here, right? A whole bunch of other components have already executed on a server and did their thing, whether it's rendering the header over here or rendering the footer on the bottom, or rendering the head, which contains a bunch of things, styles, and so on and so forth. Like those are all examples of other components that doing their thing to kind of build up the page for you, right?
Right.
So at this point, we get here and we say, okay, so we are at a /clock route, right? And we are at the clock index TSX. So this basically says, go render this particular clock. And I was playing with previous demo, so let me just revert this. Okay. And so this particular component, it creates an array of 60 items and then fills it in with items 0, 1, 2, 3, 4, 5, and so on and so forth. It creates a paragraph that has some text on it. It tells you to go scroll. It renders the items just so things can become below the fold. And then it says, oh, there's another component called clock.
Okay.
Right?
Yeah.
So if you know React, you look at this thing and you go like, yep, that's exactly what I would do in React. Nothing's different. The only thing that's kind of different is you have to wrap your component in this, what we call component $. And the $sign is basically just like there's use methods that have special rules.
Mm-hmm.
The $sign is similar, and it has also special rules. And basically what it says is, I want to take this function in here, and I want to see if it could possibly not have to be downloaded.
Okay.
Right? I want the framework to kind of figure it out. Like, is this even needed? Kind of a thing, right? And so it's a hint, right?
Okay.
Yeah, it says like, basically, what it forces the system to do is make it this particular part lazy loadable. And so we're kind of hinting to the system is like, maybe this is not needed. Like, see what you can do with it.
Okay, cool.
Okay, so we go a little further, and so here we are defining our clock, and in our clock, same exact thing. Maybe this is not even needed. We need some styles, so make sure these styles are present. We create a storage for our hour, minute, second hands.
Wait,
right?
But the styles as also the $sign means that maybe you don't need the styles also as well.
Yeah, because if this is the first time you need the component, then you certainly have to download the styles. But if it's the second time, then styles are already downloaded, so you don't need to re-download them again, right? So depending on the situation you find yourself in, maybe here you have a button that adds additional clock, right? And so when you add additional clock, you need to be able to. Yeah, you need to be able to add it, but you don't need the styles because those are already downloaded.
Right. Cool.
Right. So then you create your store. This is basically where you're going to store your information, right? And then you have a client effect function that goes and all it does is that every second runs the update, which then computes the new angles for the clock, right?
Yeah. And I
finally,
guess it's similar to use effect of React because it's named the same.
It is very similar, yes. It's very, very similar, but there's a difference, and we'll get to it in a second. And then finally, you have your JSX saying, like, this is what the clock should render out, right? So this is your JSX for the output.
Cool. Okay.
And the strange thing is, right, is that when we actually go to the network tab and when we actually make the view appear, the only code that actually downloaded, sorry, this happens with Vite. I need to restart it because it gets confused. Okay. The only code that downloaded is really the use client effect code. And that makes sense, right? Because the use client effect basically says, go run every 1 second. And so when you have a client effect, one thing you should be asking is like, well, when does it run?
Yeah, I don't see a dependency array over here.
Well, but that's fine. In React, it's the same way, right? If there's no dependency array, then it will run exactly once.
Yeah.
Yeah. So the way, one thing you need to answer is like, when exactly should this function run? And so in the world, in existing frameworks that have hydration, the answer is very obvious, which is, well, this particular thing runs when the component becomes hydrated, which means at the very, very beginning, right?
Right.
So in existing systems, the answer is very obvious, but Qwik doesn't have hydration. And so the question then becomes like, well, when should it run? And because there's no hydration, we kind of scratched our heads and said, well, what does it make sense logically to run? And the answer we came up with is, well, when it's visible, right? Like if the component is not visible, then you don't need to run its client effect. But if it becomes visible, then you do need to run its client effect.
Right.
And so in Qwik, when you have a use client effect, the default behavior, you can override this, but the default behavior is to execute this when the component becomes visible.
Okay, I see. So every time you do the $signs, so that's the default behavior?
You have to do that. Yes. You cannot write it without the $sign because you can't import this without. There's no such symbol. Like if you try to import it like this, it's like it's not going to work.
I see. Okay.
So these $signs are basically just part of the API surface of the framework, and you don't really have much of a choice of whether you put them there or not. Like they're just there, and you just have to use them.
Right, so it's more for the developer experience to let them know that what it's doing.
Yeah. Yes. That's exactly. It's basically a hint to the developer saying special rules apply here. In other words, what's happening here is that we're saying not everything that's valid JavaScript is actually valid Qwik code here. And you have to understand these rules. And the rules really come down to rules about serialization. Basically, this stuff has to be serializable, right? And Qwik has a specific meaning to what it mean by something being serializable.
Okay.
Cool. But I want to point out this thing is that there's this JSX here, and this JSX actually never downloads. This Vite is being difficult again. We download the use client effect, right? That makes sense. Yeah. We download the framework, which makes sense, but we never downloaded this JSX because if we did.
Because we will see this console log, but it was rendered on the server.
Yeah, we'll see it on a server, right? On a server, we see render clock, but we won't see it on the client.
So we receive the HTML part, which was rendered on the server side, and then just download the code that updates the HTML.
That's right. And this is what we mean by removing the duplicates, right? Like the system understood that all of this stuff that you have in HTML right here, all of that is duplicate, and you don't actually need it in the form of JavaScript because like there is nothing I can do in the client to actually affect this.
Yeah.
Now, what I find is super cool is just how minimal the system can be. So there is a listener here that when I click this, it downloads a piece of code that writes out test, right?
Mm-hmm.
But what's crazy is that we didn't even download the framework. Like if I show up over here, then I download the use client effect and then the framework downloads. But in the case of a test, the system even understood the fact that, well, the code that you need to do, you just want to write console log. And this thing doesn't even need a framework. So we won't even ship the framework to you.
Cool.
So it's extremely fine-grained.
Yeah, I'm running through my head the lazy loading system of like an SPA of React. When I use a lazy loading, I lazy load the entire module. So I'm guessing it's also with the JS6 and stuff. So yeah, okay.
Yeah,
sorry,
so actually let's
thinking out loud.
Let's compare the architectures of different systems.
Okay, cool.
So pick your favorite framework. They all work this way, that you have a server-side rendered HTML or SSG'd, right? Either one is fine. And then you see a page, but it's gray. It's not interactive. You can't do anything on it, right? And so the browser has to download the application code, and then it has to execute the application code. And as it's executing, it's making things interactive. And this now page becomes interactive, and you can do whatever you want on this particular page, right?
Right.
Qwik is different in the sense that you get this page that is no JavaScript executes. And then if I go and click on something, then only that particular component kind of wakes up. But even that is actually a stretch, because as we saw in the other example, when I clicked on a paragraph, when I did a click, the click, would only write out the console.log. And so nothing else happened, right? There was no other waking up of a component or anything like that. Like there's nothing to talk about, right? But the point is, you can kind of interact with this component. And but that's not all you can do. For example, let's imagine this would be a button that affects this other component. And so there's a relationship that the system understands, is like, when you interact here, I actually have to wake up this component here. So let's say this is a add to the shopping cart button. If I click here, then this component over here has to get re-rendered as well.
Okay. So how does it work?
And you want the secret, huh? But actually, the thing I'll show you how it works in a second. Yeah, I'll show you how it works in a second. The thing I want to point out is that when you interact with a particular component, like let's say you interact with this component right here, notice that neither the parent components nor the children components had to get woken up. And that's the kind of the core magic of it all, is that the whole lazy loading or waking up system is extremely fine-grained. And it always does just the absolute bare necessity to perform this particular operation and nothing else.
And you can do it thanks to reactivity graph. Am I guessing right?
Correct. Okay, so you're asking, how does this magic work? Okay, so let's look at the magic. Oops, let's not scroll it into the view. Let's find our clock. And so our clock has on cue visible right here. And one of the things is the font big enough?
Yeah, I see it. I don't know if they use it.
Okay.
If I use it.
Here.
Yeah, that's
one of the things we could do here is we can change this attribute to click. And now when I scroll the clock into position, nothing's happening to the clock, right?
Okay.
Until I click on the clock. When I click, then it wakes up and starts running, and you can see the updates are happening every couple of seconds.
Cool.
And so what we do here is we serialize the behavior of the particular component, right? And so in this sense, we are creating a synthetic event, right? This clock has a synthetic event called QVisible that we fire to kind of wake it up. And what follows here, but this could be like mouse move or click or any other event you're familiar with.
Okay. What
follows here is a URL where the code should be downloaded from, and what symbol should be executed. And then this bracket 0 is super important because that actually allows us to serialize the state. So let's go back to the clock. Here's our clock, right? So what's actually happening here is that when you have a $sign, you're telling the system to grab this function and essentially do this.
Yeah. Okay. Export it.
But here is the problem. Notice what happened here. This store is captured, right? And so when you refactor the system, this won't work. And so what we have to do is we have to make a special something like this. We have to restore the store before we can kind of execute the code over here, right? So we have to insert this piece of code here, and then the rest of the code gets refactored as you saw over here.
Oh, okay.
And that basically allows the whole thing to work. So let me just put everything back. So every time you see a $sign, what you're telling the system is, I want to make sure that at runtime, if I need to, I can directly get a hold of this function. Because to get a hold of this function right now requires that the system executes the component. And then as the component is running, it gives the function to the framework through this method.
Yeah.
And by exporting it,
but
that means is that every time I want to get a hold of this function, I have to execute the code around it.
Yeah, you need a state.
Right. And so by making the function exportable, by allowing us to kind of pull the function to the top level and do this kind of a transformation on it, we can basically do this operation without, basically this is kind of how it works, right? So the magic is we want to take this code and break it up into pieces so that we download just the basic stuff necessary.
Yeah, okay, I got you. Okay, so you just export the code and you're using the global state in order to keep the state so you can resume the application. Okay, that's cool. I got you.
But also
I know I had a question earlier. I was thinking about the caching system, because if you are caching your website and you now need to you now change a block of code which is serialized in the on-click event or whatever event it is, you need to make sure that your cache is not, it's not for too long because you need to change the code. Am I right?
So all of that is taken care of for you. So we can get into caching if you would like. We can talk about it. As a developer, you don't have to think about it. The right things will just happen.
Oh, thank you.
Okay, how about I show you one more bit of information and then we can go talk about caching, because that's a good question. Okay.
Cool. Yeah.
Okay, so the thing I want to show you is that here we are updating second, minute, and hour. So let me just refresh this page. And the Qwik stores all of the state information inside of this JSON file. Yeah. And inside of this JSON file, what we have are these things we call subscriptions. Basically the reactivity graph. And what this says is that if the hour, minute, or second property on this object gets modified, then you need to go and update the style property of object B, C, or D. And if we go and find that object, we should see clock. And here we go, B, C, or D. Yeah. See that?
Yeah.
And so this is the reason why the system doesn't have to download the template, so to speak, right? The JSX.
Oh, okay.
Because in this particular case, the system's like, oh yeah, I just need to update these properties. It also makes the system reactive, and reactivity is extremely fast on updates, right? So because the JSX, like in React, the JSX constantly has to get re-executed all the time, right? In order to update the UI. Right. And this is why systems like Solid are so fast, because in Solid.js, there's full reactivity present. And so we also have full reactivity. And so in this particular case, we're just updating the style property directly. We're not updating anything else. And so it's extremely efficient in terms of performance.
That's great. And I want to ask also about the developer experience, because the learning curve the learning curve. How much do I need to learn in order to? I think we already seen a bit of it because it's really similar to the frameworks we know. But I will ask you anyway. How fast can I go?
It's very similar to React. So all the JSX systems, whether it's React or Solid or Preact or any of those, once you know one, it's extremely easy to go to the other one because it's the same kind of a mental model that you have present here. The only difference here is that you kind of have this additional, these dollar signs that you have to kind of understand.
Yeah.
And again, just like a use method has a particular set of rules about like where it is allowed to be placed and where it's not allowed to be placed, right? The dollar signs also have their own set of rules that you kind of have to understand. But once you understand those rules that are pretty simple, it's relatively easy to kind of work with them.
Cool.
So from a developer point of view, what I think is super cool is that you're essentially building your application the way you have always built your application. You don't really have to change your behaviors. Yeah, the API is slightly different and there's a few dollar signs in a few places. But for the most part, it is exactly how you would build it before, right? The only difference between this line of code and an equivalent line of code in Solid and React or Preact would be that this dollar sign would not be here, right?
Yes.
Besides
I tell you
that,
what's on my mind though, what troubles me, what you said earlier about the ecosystem, because you know React and other frameworks have this entire ecosystem of tools and libraries which everyone uses, and the question is, does Qwik have them, or do we need them? Or I'm guessing we need them. But
we don't have that big of an ecosystem. Oh, I don't have this demo already. I'm so sorry. It's not running. I need to upgrade to the latest one. We can actually execute React components inside of Qwik.
Really?
So React components won't get all the benefit. I apologize, this demo is broken right now. We will not get all the benefits of lazy loading and all that stuff, but you can run them and you can mix and match them, and you will essentially every single every single React component becomes its own island. So you kind of get Astro for free. This component will not be hydrated until you either mouse over it or you set up the rules by which you kind of decide when to wake it up. So in this particular case, I think it's React index. Let's see. Oh, that's reactivity, sorry. React/index. Quick React, here we go. You basically say unvisible, right? So this piece of code here executes when a component becomes visible. So like if I take this away, then it renders the component, but the component isn't hydrated because I told it that I don't want it to be visible. But you can, for example, add an event to it. So on click, let's see if that works. Old version. Sorry, I need to upgrade the version of the demo. But you could have added the click listener on it, and it would work the way you would expect. I really have to update this demo. This is embarrassing.
Yeah. So I'm guessing it leads to the next question, which is migrating, right? If I have a React React application, so I can kind of easily migrate it, right?
Yes. Because you can start with React and you can wrap the React components inside of Qwik components, and then you can slowly migrate from one to the other or keep using it. As of right now, React will have a much richer ecosystem of whether it's widget libraries or chart libraries or all these other parts. But by being able to kind of wrap it, you get to reuse it.
That's cool. We have a question on the chat. What is the equivalent of React router in Qwik?
So let's talk about a router. So we have kind of a Next.js mental model. So you go to our routes, and these directories here that you can see, those represent the routes, right? So we were showing you a clock demo. And so inside a clock, you have index.tsx. And so when you go /clock, it will render this particular thing. If you wanted to go to, let's see, what else do we have here? Hello world. So like this one over here, that's hello. Right, so /hello, and that was going to be rendered out of here, and that's this guy that's being rendering. What I find interesting, by the way, about this hello world is that in this particular case, because there's no interactivity, even the quick loader is not added over here. So it completely removed all of the JavaScript code.
Cool. By the way, we didn't talk about, like, it's a full stack framework. So we didn't talk about like, request and response and how do you.
Yeah, so I'm actually building this demo here. I'm in the middle of building this, so maybe we can talk about it. So what I want here is I just want to have context, and then you can kind of type here and maybe filter them out. This is not working yet, so I just started working on this. But you want to get a list of these items, right?
Mm-hmm.
So let's look at how this works. I need this demo. And let's see. So it's in the here. So here's our component. Sorry, I hear myself twice. Okay, good now. So okay, so here's our component, right? So this one says, first of all, it is inside of the routes folder, contacts, and then inside of it is index.tsx, right? So we know that this is going to be served on /contacts. So if you go to /contacts, like you see over here, you see the list over here.
Okay.
Right. And so then normally the way this would be run is that this page would render on the client, and the client would make a request to get the list of names. And then when the response would come from the server, the list of names would show up, right?
Right.
And so let's see how this thing works in here. So what we do is we declare a component and we say, I have an endpoint. Mm-hmm. And this endpoint is tied to onGet over here. And so basically this says that this code, this endpoint will get the response of this object, of this function. So it's kind of weird to understand, to kind of follow through, but this is server execution.
Yeah.
Right. And this is both server/client execution.
Yeah.
Except in this particular case, there's nothing executed on a client because there's no behavior here, right?
Mm-hmm.
But in this case, what we're doing is we're just kind of cheating, and I created this fake database.
Yeah.
And I, say like, oh, this is our response. These are our people here, so there's nothing really special in here.
Yeah.
Okay. And so I'm just responding with the context like you see over here. And so now we are inside of the endpoint, and what we do, we have this concept of a resource, meaning that it's essentially like a glorified promise. And so we're saying like, look, you need to wait for this promise to resolve.
Mm-hmm.
And until you're waiting, you render pending.
Cool.
Once it resolved, then go and render the contact list. And then the contact list is yet another component here. And this contact list renders the individual items in here, right?
Yeah. So this is a GET request. What about POST and others?
Right. So you just like it says on GET, it could be on POST, on a bunch of other methods in here. So one of the things we could maybe make to work is just make the search component works. How's that?
Yeah. Sounds good.
So let's see. We have our input here,
mm-hmm.
and we need to start listening to that event, right?
Mm-hmm.
So we say on key up, or is it on change is the proper way to do this? On change. And so let's say we have a filter, so we need to store the data somewhere. So we say const filter equals use signal. So this is a way of, and by default we have nothing, and this one's going to be a string, right? And so now we basically just say that when there is an event, we want to do is say filter dot value is equal to event dot target dot value. Okay. So all we're saying is, just filter this out, and maybe I'm going to just print out the value here just to kind of see what's happening. So we'll say filter dot value, just kind of, you can see. So as why is it not running? It is running. Oh, you need to go out of it, right? Because it's on change. This is why I always struggle with this. Let's do this one. Okay, there we go. So now it goes and updates the text, as you can see immediately, right? And again, if you go to the network tab, we had to download our listener, right? This is the thing that updates the target, and we have to download the framework, but nothing else downloads. And I think that's kind of cool. Okay, so instead of doing this, I think what we need to do is filter this unresolved. So we are going to pass this information down. So filter is filter.value. So here we're also going to say filter, which is a string. So we're saying that, hey, when we grab the list, we also want to have a filter in here. And so we pass the filter down here. And we are doing our map. So before we do our map, we do dot filter this. And so the expression we want to do here is contact. And so we want to say contact dot name dot index of props filter. So if that contains, if that's equal to, we keep it, right? So if equals to -1, is that how it works? Let's see. It's case insensitive. Okay. Name dot to lowercase. And so also dot to lowercase. Okay. There we go. Okay. So now filtering is working. And again, like, let's kind of reflect back what just happened, right? We added the behavior in the traditional sense, like this is exactly how you would add it in any other framework, right? Nothing here was surprising. And yet we have this strange behavior that we have no JavaScript. And when I hit M, we download just the listener for the, right? The framework itself, right? And then we download the JSX associated with the contact list, right? Notice we're downloading just this component right here, just the contact list component, right? We completely skipped this component right here. Even though we had behavior over here and there's a state that's being kept in here, this component doesn't even download. It just completely gets ignored. And we directly go and only download this component because we understand that this is the component that's actually required. And notice this component has a style in here, right?
Yeah.
But when we downloaded the style actually got removed. It said like, oh yeah, this, the style is in this other location. And oh, by the way, right now these imports are super long because we're in dev mode. In production, all the imports would be super tiny. So you know, because it looks like there's more code in like how to download it than actually, the thing we're trying to hide. But in production, this would be much, much shorter.
Okay.
And so I think this is kind of super cool and point of good reflection, right? That it is unbelievably surgical about like, I know exactly what I need to download and nothing else.
That's crazy. It's mind blowing actually.
Thank you. That's the response I'm going for. Like if your mind isn't blown, like you're not understanding what's happening here.
Actually, I'm not that excited because I'm trying to grasp all of this and trying to figure out how does it work behind the scenes. But the beautiful part is that I don't need to know. I just write basically the same code. The developer experience looks great, and I get excellent performance without doing anything really, really, different. So this is great. Actually.
So we should talk about it for a second. So I think the way it works is that most frameworks say like, my job is to do client-side rendering. And then you add a meta framework like Next.js or Remix on top of that says like, well, I'm going to do some work on a server-side rendering, right?
Mm-hmm. Yeah.
But what I think is interesting that Qwik basically says, like, my job is client-side rendering too, but I'm also responsible for server-side rendering. I'm also responsible for creating the correct set of bundles. I'm also responsible for lazy loading, for serializing the state from the server, and for every other thing that you can possibly imagine, for like lazy loading, prefetching, getting everything up and running that you wouldn't have to think about in a normal system.
Yeah, I agree. I tell you what, though, the only thing that bothers me is what I asked you earlier. And, you know, we have all these different frameworks, which is, I love it. This is why I love the front-end world. But what would it take to, you know, that people will adopt Qwik? What is the size of the community? What are the challenges? How quickly can I get an answer to a question or challenge that I have? Where can I find it?
So the community is great. So we have a community on Discord. As you can see, I can barely keep up with all the messages on the community. So it's a super vibrant community, several thousand active. I don't know, I'm not sure they're all active, but certainly several thousand members. As you can see right now, we have almost 1,000 members online, right? That is not even counting the members that are not even online. And so the community is super active. I think what it comes down to is right now we're at the kind of beginning phase, and the thing we're going after are people that really feel the pain of slow websites, right? So let me just give you an example. Let's say you're Nike.com. Let's see how you perform. And so there's two parts in here. There's this box that shows up immediately and a box below it that takes a few seconds to run. Mm-hmm. This box here is called Core Web Vitals. Yeah. And what this is that when you're using Chrome and you navigate to this website, Chrome sends back anonymous information about how long did you have to wait for different metrics.
Okay.
And then you as a developer get to see it over here. So what this is saying is that on average, it took about 5 seconds for the largest contentful paint to show up. It took, you know, basically all these numbers that you see, time to first byte, all this stuff here is it took quite a long time. And Google has basically said, you should strive to stay in the green. And they made particular numbers for it. Why is this taking so long? It should be done by now. I don't know why it's not working.
Try a different one, maybe.
What's a good one to go to? I don't know. We'll see what comes up here. And so this number here is kind of the lab results, the one that's not showing up. Let's go to the previous one, right? So here you have, this is what the Google sees in the wild. And you can see that all of these numbers are really good. And so Google says that, yep, Builder.io is passing all the stuff. And then this is your lab data. This is basically Google running your website on an emulated device and then returning what it sees on an emulated device, right? And there's a difference between emulated and the actual behavior, right? So this is actual behavior here. This is emulated.
Right.
And this is why actually when you go to our render/next, right? The actual behavior, people don't go to the URL. So actually it looks like everything passed, but it's because it's running Qwik, right? So this is actually coming from the Qwik side. And then this is what would be the case if it would actually be running Next.js. I don't know why this is not rendering. There we go. So here's your target, right? And you can see that target has failed. So according to Google, this isn't good enough. They should do better. And you can kind of see the numbers. You know, they're basically saying, look, on a mobile device, it can take as long as 30 seconds before you can click on a button. 30 seconds. That's unbelievable, right?
How can you explain it? I mean, Target, like it's a big corporation, right? And they lose money.
So
right?
I think the answer to that question is that they don't really have a choice. Like, what exactly are they supposed to do different? So the thing is, If you look at real world sites, this is kind of a normal number. As a matter of fact, I'm going to argue that 26 is actually a good number. Like really? Many sites are in single digits.
Wow.
So, number one thing that they tell you to do, reduce JavaScript. Yeah. That's nice, but like, how am I supposed to do that, right? Like, again, going back over here, I need my framework to be able to attach listeners, and therefore my framework needs to download the JavaScript, execute the JavaScript, run the reconciliation. Like, what exactly am I supposed to delete from here? Like, it's not like I can do this, right? And people say like, well, you should be lazy loading. I'm like, really? But that doesn't help. Like, lazy loading helps for a component that's currently not on the page, like a separate route, right? Yeah, right. If it's a separate route, you can lazy load the route. That's fine. But if the component is visible in the server-side pre-rendered stuff, you have no choice but to execute the component, because you never know if the component might have a listener or not, or might have children that have listeners, right? And so lazy loading is only useful for components that are currently not in your render tree. They're not useful for components that are in the render tree.
I just remember a question I had earlier, and I forgot to ask you. What does happen if I have a big chunk of code which I need to load, to resumbility? I mean, how does it affect? But I mean, so far you showed us like small chunks of code. But what if I have? I don't know. I don't have an example, but I'm guessing there is.
Yeah, let's talk about that. So the first thing I want to make sure we're on the same page here is that the worst possible situation for Qwik is that it has to download all of the code.
Right, of course.
Right? But it doesn't have to execute or reconcile the code.
That's right.
So in the worst possible case, Qwik is already in a much better state than the existing system.
Yeah, I agree.
Okay. So under no circumstances in any possible world will you ever get in a situation where a hydration is cheaper than resumability. No. And I think this is an important thing to understand. Like, even in the worst possible situation that you can possibly contrive, you're still better off with resumability than with hydration. Okay, so your question is like, what happens in complex pages? So let's go to our home page, and I'll actually show you a complex page. So here is a search button right here. And let's go to the network tab. And when I click the search, notice that it came back from the service worker, right? Service worker responded here. And this is this could be further optimized better, but we want to make this automatic. It's not there yet. But one of the things I want to show you is that we actually downloaded a lot more than you think. So, well, before we go there, the service worker, why is the service worker here? It's because when we get this page up and going, we install a service worker here, and that service worker goes and eagerly downloads all of the code that is relevant. It doesn't download the duplicates, just downloads the relevant code. And one of the things I want to show you is that if you go to the bottom, you can see that this one file doesn't contain one thing. Like previously up to now, when I was showing you demo, every interaction caused a separate file download. Here we're putting multiple symbols into a single file, right? So this one has 3. This one has only 1. Let's see. I think one of them has like huge. Oh, that's not it. I think this one's going to have a whole bunch. No? One of them has a whole bunch. Of course not now. I'm going to have to go through every single one. Is this one? This one looks like it is. Here we go. So all of these symbols got collocated together into the same exact file. And so this QDEF is probably the first one that downloads. I go to network. Yep, DEF right here. Right? It's one of the first things that downloaded.
Okay.
And so what we have here is 1, 2, 3, 4, 5, 6 of them. And this should be improved because let's do document.add event listener Q symbol. And we say event and then console.log e.data. Refresh this page. It's not Q symbol. Is it just symbol? Oh, maybe. Oh, I think it's without the colon. I think maybe. I can always never remember. There we go.
Okay.
It's not data. It's what is it? Oh, I forgot.
Target.
Sorry, I forgot to run the code. Custom event. It's detail dot symbol. That's what it is. Sorry.
Okay.
Let's do this. I should have it memorized. Okay. So now when I click, it actually shows you all of the symbols that were needed to perform this particular operation, right?
Yeah. Cool.
And then I can take this information and I can go to is it here? Yes. So in this Algolia search, these symbols are loaded. So basically these symbols here are the same symbols that came up over here. As you can see, this one is I5C1, right? And basically this tells the system that it needs to put all of these symbols together so that you don't end up with a waterfall. And it is currently the process is manual, that you manually have to do it. But we're already working on the ability to collect like statistical data on a server and then automatically create ideal bundles based on real world user behavior.
Oh.
So imagine that the way it would work is that you create your first version of your website, you push it out, and people start using it. And as people use it, you collect statistical information about like how do people actually use it.
Huh.
And then once you collect that information, when you create a second version of the website, right? Because like you're constantly pushing updates, right? When you push the next update, you need to make a build. And when you make a build, you will then automatically create bundles that are, contain the correct set of symbols correctly. So there's a couple of things going on here, right? First of all, we have a service worker that automatically starts prefetching all the related code. And then we have statistical information to make sure that we put the symbols, we coalesce the symbols in such a way that you have to download the least number of chunks. These chunks have a hash inside of them. So this hash here, it depends on the content. And so when, I think you asked me a question earlier that I forgot to answer, which is what happens when you change a function? Well, what happens is that particular SHA here changes. And so we know we have to reload that particular SHA. Right. But these symbols, these hashes are stable between builds. So even if I make a new build, this ID here doesn't change. This ID has to do with where the particular symbol is within your source code. So unless you do like major refactoring of the source code, it will be the same ID between builds. And this is what allows us to use information from the previous build to kind of feed the next one.
Yeah, okay. Okay.
And let me see. Here. Okay, so here is an example.
Cool. Example is good.
I don't have sorry, I thought I had more examples. But if you behave right, so there is a sorry, I thought this was already running, but it's not. Basically, we collect the symbol information that I showed you basically through here, and we send it periodically to the server so that the server can do statistical coalescence and kind of figure out like which symbols are always coming together. And based on that, the server can then suggest to you what is basically it gives you back this thing. It gives you back saying like, create these bundles, create this bundle, this bundle, this bundle, and this bundle.
Oh yeah, I see. So
and
maybe
then,
you can answer talk about a bit about the cache? Because I think it's related, right?
Yeah, so the cache it happens in here. And oh, by the way, one of the things people oftentimes do is they click disable cache and then they refresh and then click here and then they show like, oh, look how small. Let me try this again. Empty cache and reload, and then they click and they're like, oh, look how slow it was. Oh, it's still pretty fast, but like sometimes they'll say like this is slow. But the thing to understand is that if you see here, let's go to JavaScript. The thing to understand is actually let's do throttling fast 3G here. I can show you now. Let's slow click. Oh, it's still fast. Oh, because now the service worker showed up. Disable cache. No. Come on, I want to show you the slow response. I clicked, nothing's happening, and now it shows up, right? And people are like, yeah, this is always going to be slow. But look what you just did. You clicked disable cache. And because you clicked disable cache, you are now fetching the symbols directly instead of fetching them through the service worker, right? So if I uncheck this thing and I refresh now and I click, it's instant. Right?
Yeah.
Because the service worker responded. And then people say like, oh, you're cheating. Like the service worker is essentially your cache, which is true. So let's delete the service worker. Let's go to service worker. Where is the service worker? Yep, this one, unregistered, right? So now we don't have a service worker. And now we're emulating that we came here for the very first time. So we go empty cache and hard reload, right? And so we come here and now we click. And it's instant because one of the first things the service worker did is it started fetching the data. It didn't wait for me to click. The service worker immediately knew like, oh, those are possible interactions in the system. And so it immediately started fetching the JavaScript before even the images showed up or everything else.
Yeah.
So the whole thing is just optimized for instant on minimal JavaScript. Even on slow networks, even if you're like offline or whatever, in a way so that you get the best possible experience. And again, as a developer, you don't have to think about this. Like it's just part of the framework. It's just how it works.
Yeah, but you can, right? Because it said earlier you can customize it.
I mean, you can customize it. You can definitely go down the rabbit hole and customize it. But for the most part, you don't have to do anything to kind of do it. Mm-hmm.
That's crazy. So you're kind of I don't know, a front-end AI framework, something like that.
Yeah. I mean, that's what statistics is, right?
Yeah. That's amazing. That's amazing, actually. Okay, wow. I'm mind-blown. So wait, I have a couple more questions. And we took already a lot of your time, and you also need to work. So although it is your work. So actually, maybe it leads me to the next question, which who is behind Qwik? Because I guess you're not alone over there.
Yeah, so no, we're not. So there's three of us. Oh, look at this slow slow 3D network, 3G network. So that's myself. I created AngularJS and Angular. So, I have a lot of experience in this particular domain. Adam Bradley, he created Ionic and Stencil. I'm not sure if you're familiar with that, but
Ionic.
Both of these are super big, super popular systems. So Mr. Bradley certainly knows a lot about frameworks as well. And then, of course, we have Manu, and he created Stencil, which is together with Adam, but he also created this other framework called Jin. It's popular in Go language. So it's a Go language dependency injection kind of a thing. And so the three of us kind of, our full-time job is essentially to kind of focus on this and make this happen. And the reason we want to make this happen is because on the end of the day, Builder is a headless, as I said, headless visual system. And we have some pretty big names that are using our technology, and they always complain to us. They really want to make sure their websites are faster, right? And instead of telling them like, well, it's not our fault, go talk to Next.js or Angular or React or whatever, we figured like, well, how about we provide actual solutions for them? And so we provide two solutions for them. One is Qwik, and the second one is Partytown. We haven't talked much about Partytown, but Partytown is for taking the third-party scripts and moving them into web workers. And essentially Qwik is taking the first party scripts and moving them to web worker. And so most of these companies are actually super interested in Qwik. We're already having discussions with many of them and, working on pilots where we take like their simple landing pages and try to convert them over to Qwik as kind of a starting point. And as we build up credibility, the idea is to go upstream and eventually is to have fully interactive sites.
Nice.
And so
you already have like a real world applications over there in production?
We have real world applications in production. Nothing big, but people are already using that. We have about somewhere around 40 sites or something like that. I mean, it always changes, right? Like I don't check on it every day. But I want to actually show you one more demo before we go, and I think it's important.
Oh, yeah.
So we are focusing on e-commerce, not necessarily just e-commerce, but like sites that kind of do e-commerce. Why is this so slow? Is it because it's because I turned on 3G emulation. Wait. No throttling. No, it's still slow. Oh, I wonder if what? Sorry, they're probably working on this thing and they're probably
diverted.
No, they probably are. One of the things we want to show off is slow rendering and how the page is performant even with slow rendering. And so I wonder if they have that enabled in there.
I see.
But this is a kind of an e-commerce website. But what I want to point to is that we want to do personalization. And let's say you have this URL right here, Qwik Dream Demo. Okay, so let me grab this. And let's go to this URL. And this URL should, there we go. So this is there's a separate URL that just knows how to render the hero image, right?
Yeah.
And so each of these boxes you see are actually separate URLs that render different parts of the system. And the reason why this can be fast is that normally the reason pages are fast is because they're served out of a CDN. But the problem with CDN is that you cannot personalize it. And so the only kind of personalizations people do is they create basically subcategories and they say like, we sell clothes. So I'm going to split this into clothes for men, clothes for women, and clothes for children, right?
Okay.
And then what I can do is I can rewrite the URL based on a cookie so that a different CDN can respond depending on the request.
Mm-hmm.
Okay. But you can see how like limited that is, right? Because you can't render a person's name or anything like that. And the reason is that it would be too expensive at the edge to run full rendering. And also, there's a whole hydration problem, et cetera, that we have to deal with. And so instead, what if you could have a separate URL for all of these parts? And then each of these parts can themselves be CDN cacheable, right? Like everybody gets the same menu. Not everybody gets the same shopping cart, right?
Okay.
And you might have, yours might render with a different number here.
Yeah.
There is only so many hero images to show. Even if you're a large company and you have 1,000 hero images to show, that's still a finite number. There's only so many products to show. And then of course, there are the comment section below. And what's actually cool is that if I make it smaller, if I refresh, I believe the comment sections won't even load. So actually, let me just do it with JavaScript off. JavaScript here. I'm sure that this is slow because they're probably testing something because there's no reason why this thing should be this slow. Notice the comment sections didn't even show up. They said loading, right?
Okay.
And that's because when the JavaScript is running, and I refresh this, right? The page only loads if I start scrolling, right? So only on visibility. So if I scroll to the bottom, it says loading, and then it actually shows up the right stuff. And so these are all different kinds of tricks that you can use to make sure that you render an absolute fastest response and it's fully personalizable, right? So like when I show up and they like, if I go to Amazon, right, they know that I like 3D printing. So they'll show me a hero image of 3D printer, and they know that it's been a while since I purchased my filament. And so they show me like, hey, you know, last time you purchased this filament was 3 months ago. Like maybe it's time to buy another filament, right? And all of these things. And you can't do that if your only choice is either the whole page is cached or everything has to be rendered, right? The whole trick here is that you can decide on individual sections what is rendered and what is cached. And by doing that, you can get, you know, full personalized performance that you can't get today.
Yeah, that's a game changer, actually.
I think so too.
Yeah, that's cool. By the way, I forgot to ask you, how do you debug this application?
Very much the same as you would debug normal applications.
Because you don't have the code yet. So how do you like put a breakpoint on something that you don't have? Or you do have a source map, or I'm guessing you have a source map.
So first of all, you can put a breakpoint on a server, right? So this is a server. And here you can put breakpoints, whatever you want. In here, you're right. So if you wanted to debug a clock, so the way you could do that is, let's see. Source routes and box. Oh, is it here? No. Oh, no, it's going to be source. Here we go. This is our clock, right? So you can put a breakpoint here if you want, and then you do refresh. And when you come here, you know, the breakpoint stops. So it's very natural. And we can see that the source map looks like it came from your file, right?
Mm-hmm. Yeah. Nice.
So even though it's a separate file and it's all broken up, when a source map gets put together, it puts together the whole thing for you. So yeah, all of those things kind of just work out of the box. It's the experience that you would expect. I think the only kind of extra level of kind of understanding is that you need to now understand that this debugger is for the browser and this debugger is for the server. And sometimes you might have to debug one or the other.
Yeah, of course.
Yeah.
Okay. I think, well, I have couple of more questions, but I think we have we quite talked about a lot of things over here. We need some time to digest it, you know, understand. Yes. It's pretty genius, I have to say. And
thank you.
And thank you for coming. I will share the links. I will share the links below of the Discord, Qwik documentation, which is great, by the way. I saw it, and Builder.io, which is also nice. And everything you want also to mention, your Twitter. I'm guessing you're really active on Twitter, right? Or
yes.
Anywhere. Okay.
Yes, Twitter is a good place to get a hold of me. Also, just coming to our Discord channel, Discord server is a good place. And yeah, I mean, we didn't really talk about Builder, but Builder is a headless CMS that's visual, so you can think of it full drag and drop. And it's easy to update our UI with it. And so actually, many of our pages are actually built using Builder.
Nice. And okay, I forgot what I wanted to say. But actually, oh yeah, I remember. I want to ask you, do you recommend if someone is like starting from scratch and want to do a real world application for their client or company or whatever, do you recommend them using Qwik? Is Qwik ready for a real big application, or just play around with it?
It's definitely ready for big applications. But one of the things you're going to run into is that it's a new framework, right? So you might, you know, while you might find tons and tons of Stack Overflow questions and third-party libraries, etc., you might not find that with Qwik. It's going to take time for this thing to build up, right? So it depends what kind of person you are. You know, if you're a person who is just starting with the technology, then this might not be the best thing for you. If you're a person who enjoys living on the edge and finding the absolute best performance you can possibly get, then, you know, Qwik is definitely for you. As far as capabilities of the Qwik, I think all the capabilities are there. It's really just a question of you know, we're working hard right now to kind of clean up any issues we might have and clean up getting started so that you know, people have good experience. But once that gets cleaned up, I think we're going to be ready to declare 1.0.
Cool. We're counting on you. So yeah. It looks really, really amazing. We're definitely going to check it out and do some real application using it. I really like the entire magic you're doing over there. I think it's genius. It's brilliant. And then, like I said, it's a game changer. So, and really what I was concerned about is how you adapt it, because the learning curve is really looks simple and the developer experience looks great. So I'm also expecting a bright future for this framework. So thank you for that. And thank you for contributing to the community.
Thank you. We spent a lot of time on developer experience. Originally, the developer experience was nowhere this neat, this nice. But we just had a prototype to kind of show that this is possible, this lazy loading and this advanced things. But over the time, we really slowly honed it so that, if you come from a React or Solid or any of the other JSX frameworks, you look at this and you're going to be very much right at home. And I can't stress this enough. Like, basically, we made performance not your problem. Like, yes, there's always situations where you can get yourself into trouble. But for the most part, the vast majority of performance optimizations that you can think of are just going to be done for you.
We lost you for a minute. We will wait a couple of seconds. טוב, בכל מקרה, מי שהיה פה ושרד, אז תודה רבה לכולם. אני רואה שעדיין יש אנשים בשידור. אנחנו נעשה איזה, אם הוא יצליח לחזור, אנחנו נעשה איזה כמה מילות סיכום. נראה לי שהיה די מרתק, ובאמת נראה מבטיח, כאילו נראה ממש מגניב. אני אשים קישורים לכל מה שהוא אמר, וכל מה שאמרנו בתגובות. וזהו, אם בא לכם לחכות יחד איתי, נחכה לו, כי באמת בן אדם אדיר ותותח, אז נפרד ממנו כמו שצריך. ומה שהוא רוצה לדבר על Builder.io, שזה Head ל-CMS, באמת כלי מגניב שראינו שאפשר לבנות את האתרים. אז תבדקו את זה גם, אני אשים גם לינק לזה. ומישהו, Miško.
Yeah, I'm back. Sorry, I don't know what happened to my internet.
Okay, cool.
We were at the end anyways.
Yeah, it's okay. I was talking about you, how great you are. So you can sum it up. You started talking about Builder.io, or what did you start?
No, I was just basically saying that the key thing is that as a developer, you just don't have to think about it, right? We made a whole bunch of problems disappear for you, and I think that's the future of the frameworks, right? I think a lot of times. Mm-hmm.
I want to say, like, we're wasting so many hours on performance issues, so many hours, really. So I agree. Like, it is a game changer. I'm not just saying it because you're on the line, and we spent a lot of money on performance issue and testing and everything. Like, it's crazy.
Yep. Sounds good, man.
Okay. Sorry for interrupting you during the...
No worries. No worries. That's why I'm here.
Yeah. So thank you once again. We will spread the word, and thank you for joining our front-end community in Israel and sharing with us your skills, actually. And actually, this is an open source, right? So we can contribute to it.
Yes, absolutely. Absolutely.
Great. Great, great, great. So we will see you in the Discord, on Twitter, and thank you once again. Really appreciate it.